Hello Bobcats. In this video we will be looking at the 5 types of chemical reactions. So the first type is called a synthesis reaction, also known as an addition or combination reaction, or combination. And what happens here is that two or more substances combine to form one new substance. And what that looks like is we would have, in generic form, we would have substance A plus substance B, and it could be A, B plus C, it's two or more, but A plus B combining to make one substance A, B. So this is the generic form of the reaction, and an example would be, so here's an example. Let's say we have hydrogen gas plus oxygen gas, and it's 2 moles of hydrogen gas, will react to produce 2 moles of water vapor. So that's 1, 2 going to 1. Okay, so that's a synthesis reaction. The next type of reaction would be a combination reaction, or decomposition reaction. Decomposition reactions. And in a decomposition reaction, what happens is that we have one substance breaks apart into two or more simpler substances. Now, this doesn't mean that it breaks apart into individual elements or atoms, it just breaks into simpler substances. So let me give you an example. But let's look at the general form first. So the general form of a decomposition would be substance A, B breaks apart, and it could be A, B, C breaking apart, but a single substance breaks apart into A plus B, 2 or more substances. So 1 goes to 2 or more. So this is the general form for this. An example of that would be, let's say we have sodium carbonate, one substance, it's a solid, decomposes or breaks into 2 or more simpler ones. Now in this case, 2 simpler ones, not the elements, but simpler substances. And carbon dioxide. So that's 1 going to 1, 2 simpler substances. That's decomposition. The next type that we'll look at is single replacement. So the third would be single replacement or displacement. Either way you say it would be fine. So single replacement reactions. And in a single replacement reaction, one element in a compound is replaced by another element. And I'm going through these pretty quick. We're just learning the basics of it. These actually can be, these 5 types can actually be put into 3 categories: oxidation, reduction, precipitation, or acid-base. And we will go more in detail of each of these reactions as we look at the categories. Now, in the single replacement, there's 2 types of single replacement. We can have what's called a cation single replacement. So we have the cation single replacement, which would look like this. So we have element A plus compound BX goes to AX plus B. Now remember, the first is always a cation. So when we look at this, what we're doing is we're taking, and it's usually metals, so we have this metal, which can become a cation, will replace the cation in, so that's a single arrow, single replacement. So you replace the B with an A, so you get AX, cation, anion, and then the element B by itself. Single replacement. So an example of that would be if we took zinc, solid zinc, plus, so that's my metal, my element, and we have Cu, copper 2 sulfate, aqueous. This is my compound. There's the cation, and X would be the anion, sulfate. And so now the zinc replaces the copper. So now you get zinc sulfate, aqueous, plus copper solid. So the zinc replaced the copper. And this cation is almost always a metal replacing a metal, but every once in a while you may see a metal replace hydrogen, because hydrogen is also a cation, a 1+ charge. So it's usually a metal replacing a metal unless there's a hydrogen there. It can also replace a hydrogen. And then the other type is called an anion single replacement, in which we'll say we have Y plus BX goes to BY plus X. And so if we look at this, remember it's the anion, so this will replace the anion. And it's really just the halogens that we're going to look at. So we want to make sure that we are just dealing with halogens. There's others, but I just want us to look at the halogens as the anion single replacement. Okay, so let's get an example here of the anion. So if we have chlorine gas, that's Cl2, that's my Y, that's the halogen, plus, let's say, sodium bromide, that's X, so that's the B and that's the X, the cation and the anion, and this is aqueous. Now here in this case we have the chlorine replacing the bromine. So I would write sodium chloride, and it's not NaCl2. Remember, this is a 1+, 1-. You got to write it correctly, and then we balance it. And then this goes to Br2, and you got to write it correctly because Br, bromine, is a diatomic. And of course, that's aqueous and liquid. Now, and then we would balance it. So if I have 2 chlorines and 1, I have to put a 2, and then now I have to put a 2. So that is the single replacement there. Now, one thing that is very important to understand is that, and I'm going to put a star here, single replacement is dependent on the activity series. And we will talk about the activity series in more detail in a couple of videos from now. So when we look at single replacement reactions in more detail with oxidation reduction reactions. So again, we have two types, cation and anion. Cation is usually a metal replacing a metal, or a metal replacing hydrogen, or you have anion, which is the halogen replacing the halogen, or the anion replacing the anion. And then it depends on the activity series. In other words, this has to be higher on the activity series to replace this copper. So, or the chlorine has to be higher on the activity series than bromine, or it won't work. And we'll go over the activity series in a different video. Now we still have two more reactions to talk about. So the next reaction we're going to talk about is double replacement. So reaction type 4, which is double replacement reactions. Double replacement reactions. And in this case, ions of two ionic compounds in solutions, so these are ionic compounds that are dissolved in water, exchange places, the ions exchange places to form two new compounds. Okay, so let's look at that. So the general form would be, let's say we have AX plus BY. AX plus BY. Now in this case, remember, let's look at it. A would be the cation, and X would be the anion, B would be the cation, Y would be the anion. So we have the cation reacting with the anion of the other one, so you get AY plus, and then the second replacement would be the cation reacting with the other anion, so there's two arrows, double replacement, and you get BX. Okay, so that's the general form for the double replacement. And we'll look at a couple of examples in just a second. One thing I need to state is that what drives this reaction, or what makes this reaction occur, is the formation of a precipitate and a precipitate's a solid that forms in two solutions when two solutions mix. So a precipitate, water, or a gas. So we have to form a precipitate, water, or a gas. Now, the ones that are extremely important, the one that you're going to see the most of, and we rarely see the gas formation, but it's precipitate formation and formation of water. And we actually call this a precipitate reaction and an acid-base reaction when you form water. And we'll talk about those in more detail in the next videos. So the next thing is we need to look at a couple examples real quick. So if we have, let's do an example here. Let's say we have the lead 2 nitrate, and remember that's going to be aqueous because it says in solutions, plus 2 moles of potassium iodide, aqueous because it says that's in solution, produces lead 2 iodide, PbI2, and that would be a solid. This is my precipitate, so this is the precipitate that forms, that has to form here. So this is a precipitate, and we'll learn how to determine what would be a precipitate would be not in what's called solubility rules in another video. And then it also formed 2 moles of potassium nitrate, which is going to be aqueous. Okay, so that's why this one works, is because we formed this precipitate. Another example would be if we took sulfuric acid, H2SO4, aqueous, plus sodium hydroxide, so 2 moles of sodium hydroxide, aqueous. And remember, the positive goes with the negative, the OH, and the Na positive goes with the SO4 negative, okay? And so we get 2 moles, and I'm going to write, because to balance this I would need 2 HOHs, and I'm writing water this way because you notice there's the OH here, hydroxide, and the hydroxide here, so we want to make sure we have our hydroxides. And then there's the hydrogen and the hydrogen. And this is a liquid. And then the other formation is sodium with the sulfate, so that would be Na2SO4 aqueous. And here we've formed the water. So again, the reason this reaction occurred is formation of water. Now I'm not going to show the one with gas because we won't see it as often. We really want to know precipitate and water. And that's a double replacement reaction. Our last category of reactions is the combustion reactions. And so that is category 5. Combustion reactions. Now there are 2 types that we're going to look at. We've got A, which is anything reacting with the oxygen gas is considered combustion. Sorry. Anything reacting with oxygen gas whoops. And remember, oxygen gas is O2. Excuse me, I'm sorry about that. Is considered combustion. So for example, if we had magnesium solid reacting with oxygen gas, we would produce magnesium oxide solid. That is a combustion reaction because we've reacted with oxygen. Now, and all combustion reactions are very exothermic. They give off a lot of heat or energy. The other type of combustion reaction would be a hydrocarbon combustion. And with the hydrocarbon combustion, what we're looking at is something with hydrogen and carbon. So any amount of hydrogen, so CX, any amount of carbon, and any amount of hydrogen. And in some cases, you might even see some amount of oxygen, but it's really has to have hydrogen and carbon. Will react with oxygen O2 to produce carbon dioxide and water. Now, if you have enough oxygen, you'll get carbon dioxide, and this is called a complete combustion. But as you run out of oxygen, these two react and you get just carbon monoxide, so you have less oxygen to react, and so that's called an incomplete combustion. And then if you continue to run out of oxygen gas, you just get carbon. You'll always get water, but you'll start decreasing the amount of oxygen with that combines with the carbon, and that's an incomplete. So I didn't write the other part because these are the same things here. So if you take these and react them, you can get an incomplete because you have less oxygen, and if even less, it's another incomplete. And so that is the 5 types of reactions.